Hello everyone, today we're going to talk about how to take the integral of an exponential and also natural logs. So today's a really important lesson. These come up quite a bit on the exam, so make sure you take good notes, and you're going to notice a lot of parallels between the derivatives of exponentials and the derivative of natural logs and their integrals. So we're going to always start with the derivative rules, just kind of refresh your brain, and then we're going to go backwards from there. All right, let's get started. Okay, so let's just remind ourselves about the rules for the derivative of exponentials. So if you want to take the derivative of e to the x, hopefully in your head you're telling me that the rule is simply just e to the x. All right, so if you want to take the derivative of e to the x, the derivative is just simply e to the x. But when you want to take the derivative of e to the u, and remember u is a function in terms of x. So if you want to take the derivative of e to the u, hopefully, again, you know this one. It's e to the u times the derivative of u. So e to the u du. Okay, so we're going to kind of keep those in mind as we talk about now the integrals of exponentials. All right, so let's reason this out. Remember that when we take the integral of something, it's going backwards. So I want you to think about this question. If it's asking for the integral of e to the x dx, it's saying whose derivative is equal to e to the x. The derivative of what thing would give me back e to the x? And hopefully, based upon the review we just did, you'd realize that it is in fact e to the x. That the derivative of e to the x is e to the x, and so then the integral of e to the x is e to the x. So it's a nice, easy transition. Now, because we're doing the integral, remember, and this is an indefinite integral, there are no bounds, we need to end it with a plus c. Okay, likewise, if we take the integral of e to the u du, again, we need to ask ourselves, whose derivative is e to the u du? And again, if we just go back to the notes we just reviewed, we would say e to the u and then plus c. Okay, now I will make another note though, that it's not quite that easy. This oftentimes, 99% of the time, will require u substitution. So need to use u sub with the exponent. All right, so let's start working through some examples and start practicing these. Here we go. Okay, so the first one that we're going to take a look at is the integral of e to the 3x plus 1 dx. Now remember when we talked about u substitution, we said we were going to use that whenever you had a function inside of a function. Well, here you can see that we have a function inside of a function. We have the function 3x plus 1 inside of the exponent of e to the x. And so we don't have just e to the x, we now have e to something that is more complicated. So like I said, we are going to be using u substitution with these problems, and we're going to 99% of the time use our exponent as that u. So off to the side here, I'm going to start off by going ahead and saying u is equal to 3x plus 1. And just like we've done with previous problems now, take the derivative of both sides, so 3 dx, and solve for dx. So du over 3 is equal to dx. Okay, now, just like previous problems, we're going to take that back and substitute it into the original problem. So instead of the integral of e to the 3x plus 1, I'm going to say the integral of e to the u, and instead of dx, I'm going to go ahead and replace that with this right here and put in du over 3. All right, so now, of course, I have a constant of 1/3, so that can come out front. The integral of e to the u du, we just said, is e to the u plus c. So now the last thing I need to do is take and substitute back in what I know u is in terms of x, and I'm all set. So my final answer is 1/3 e to the 3x plus 1 plus c. That is the integral of that first example. Okay, taking a look at number 2, the integral of 5x e to the negative x squared dx. Once again, we have a lot going on here, okay? Try not to get yourself too confused. Try to start with your rule of thumb. Start by setting your exponent as your u. So u is equal to negative x squared. Take the derivative, du equals negative 2x dx. Okay, solve for dx, so du divided by negative 2x equals dx. All right, now let's go ahead and substitute that back into the original and see what happens. So the integral of 5x e to the u, and instead of dx, I'm going to replace that with du divided by negative 2x. Remember, we've talked about this is a success when you are able to cancel out everything that is not in terms of u. And if you look at this, I am going to be able to cancel out my x's here because I have one in the top and one in the denominator. Therefore, this can be rewritten as the integral of, I'm going to pull the 5 out front, e to the u. Actually, I can pull the negative 5 halves out front. Okay, so negative 5 halves, integral of e to the u, du. And so now I simply take the integral of that, and as I take the integral, of course, my integral symbol goes away. So the integral of e to the u du is simply e to the u plus c. Last thing I do is substitute back in what u is. All right, so negative 5 halves e to the negative x squared plus c. And that is my final answer. Okay, this next one is obviously a little different than the last couple we've done because this time I have bounds. So I have a bound, a lower bound of 0 and an upper bound of 1. But we're going to go ahead and approach this problem the same way. We're going to start with our u substitution, and then of course we'll just have to fix our bounds as we go through the process. So as I said, we're going to go ahead and set our exponent as our u value. So go ahead and do that. Pause the video. And try to get it in terms, everything in terms of u, including your bounds, and then come back to me and see if we agree with the same answer. Okay, so let's take a look at what I have and compare it with what you have. All right, so first of all, I went ahead and set my u to equal the exponent negative x. I took the derivative of both sides, I solved for dx, and so I get negative du is equal to dx. All right, now it's time to substitute that back in to the original integral, but make everything in terms of u. So I did the integral of e to the u, and then in place of dx, I substituted in for negative du. Then I worked on the bounds, and you can see I did that in yellow here, okay? I put my top bound in for x and solved for what it would be in terms of u. So it was obviously just negative of 1, which is negative 1. So that went at the top. And my 0, well, negative of 0 is still 0, so that didn't change, and that stayed as the lower bound. All I did from this step to this step was I went ahead and pulled the negative out front. And so now that is what I'm taking the integral of. Okay, so now I'm ready to go ahead and do that. So I would have negative. The integral of e to the u is e to the u, but this time I do not have bounds. I do have bounds, so I'm not going to put plus c. I'm going to put my straight line and say that my lower bound is 0 and my upper bound is negative 1. And now I'm ready to go ahead and plug in my upper and lower bound. So I have negative e to the negative 1 minus negative e to the 0. Okay, so this was the upper bound plugged in, and there's the lower bound plugged in. All right, negative e to the negative 1 is simply just negative 1 over e, right? Because e to the negative 1 pushes it down, and then the negative makes the fraction negative. All right, minus negative e to the 0. All right, so negative e to the 0. Well, this would be e to the 0 would be 1, and then the negative of that is plus 1. So we end up with this answer, negative 1 over e plus 1. That is our final answer for this problem. Okay, as we take a look at this next problem, we have the integral of e to the x times the square root of 1 minus e to the x dx. All right, so generally I said that you're going to go ahead and set your exponent as the u value. Well, would that make sense in this case? My exponent here, if I look at the e values, it's e to the x, and then inside, under the radical, it's e to the x. So either way, my u, if I were to set the exponent equal to u, it would just be u equals x. And that's not going to help us at all. And so, in fact, that is not the correct way to do it. This time, I want you to kind of go back to what we said. If we have things under a radical, okay, or inside of parentheses raised to an exponent, that's going to become our u. So let's just give that a try and see if it works out. So I'm going to set what's underneath the radical to be my u. So I'm going to say u is equal to 1 minus e to the x. All right, take the derivative of both sides. du is equal to, I would be left with negative e to the x dx. And so I'd have du divided by negative e to the x equals dx. All right, so now I'm ready to go ahead and see if I substitute this in, if I can get it all in terms of u and cancel out my x terms. So I would have the integral of, okay, I can't do anything with this e to the x at first, so I'm going to leave that there. Then I would have the square root of u, and instead of dx, I would have du over the negative e to the x. All right, so did that help at all? It sure did, because if you look now, my e to the x's are going to be able to cancel out. And so I'm left with negative the integral square root of u du. And so I can definitely take the integral of that. Everything's in terms of u. Obviously, I'd want to think of this as u to the 1/2. All right, so now I'm ready to go ahead and take the integral. And so I'd say negative u to the 3/2 times 2/3 plus c. So I'd say negative 2/3, and now put in your 1 minus e to the x. So it'd be the square root of 1 minus e to the x quantity cubed plus c. And of course that's because if I take a look at this, right, if it's to the 3/2, the denominator is your root, so that's where the square root came from, and the numerator is your exponent. So I had to take that whole u value, 1 minus e to the x, and cube it. Okay, I think we've gotten some good practice in on taking the integral of e to the x or e to the u type functions, and now we're going to move on and start to look at some natural logs. Okay, so again, let's start by reminding ourselves of the derivative of natural logs. So the derivative of natural log of x is simply 1 over x. Okay, so that was an easy one that you should know by heart and be able to get that answer right away. Okay, it gets steps up a little bit in complication when you have the derivative of natural log of u. Well, if you remember, we would do the derivative of u over u. Okay, and so those are our two rules for the derivative of natural logs. The idea here to recognize is that when you took the derivative of natural log, you ended up with a fraction, and the denominator, okay, was, in this case, just the x. In this case, whatever you're taking the natural log of. And so that was crucially important, and it's going to become important as we recognize and as we learn how to do the integrals going the other way. So let's take a look at that. Okay, so if I want to take the integral of 1 over x dx, of course I could rewrite that as the integral x to the negative 1 dx. And if I used my normal rules that I've been using all along, and some of us have stumbled upon this before and recognized that it would be impossible to use my normal rules. So let's just give it a try and see what happens. If I use my normal rules, right, it's x to the add 1 to the exponent, which would be 0, divided by 0, and then your plus c. Well, what's the problem with that is that this is not allowed. You cannot divide by a 0. And so, therefore, you get an answer back that is undefined, and therefore you can't have that answer. Okay? So, in fact, this is not at all how to take the integral of 1 over x dx. Okay? So, again, let's ask ourselves this a different way. Whose derivative would give me back 1 over x? And then, if you think about it that way, hopefully you'll recognize and remember, oh, that's natural log of x, and then, of course, your plus c. So the same thing here for this one. The integral of something over u, And again, this is going to look a little funny, and we're going to practice this, and you're going to recognize, be able to recognize what happens. You're going to go ahead and say it's the natural log of u plus c. Now, the important thing with this one is that you will use u sub again, but this time with the denominator equaling u. All right, so let's go ahead once again and start practicing these until we get comfortable with them. One thing I should say before I go on is that oftentimes you'll see in multiple choice answers that they don't just leave the answer as natural log of x plus c or natural log of u plus c. They'll actually do it as the natural log of the absolute value of x plus c. Or this could also be written as natural log of the absolute value of u plus c. And the reason why they do that, of course, is because remember you can only take the natural log if your domain, if you're taking the natural log of something bigger than positive, bigger than 0. And so because of that, they put those absolute value bars. So as we do our answers, when you're looking at multiple choice, you'll oftentimes see those absolute value bars. So you want to make sure that you recognize that. Okay, we're going to start off with a nice and easy one. The integral of 2 over x dx. And like I said, it will happen to you where you'll forget about this and it won't stand out to you, and you'll try to use our old rules. And you'll try to rewrite this as 2x to the negative 1. You'll do the add 1, divide by 0, and you'll go, wait a second, I can't have it divide by 0. And hopefully then it will spring into your brain, oh, that's why I have to recognize that you have to use natural logs. And so the one thing that you could do is you could recognize that you have a constant that could come out front. This is 2 divided by x. It's the same as 2 times 1 over x dx. So I'm just going to rewrite this as 2 times the integral of 1 over x dx. Well, in that case, it becomes even more apparent that it's 2 natural log of x plus c. And so that is that first one. Very straightforward, very easy. Okay, taking a look at the second example, the integral of 1 over 4x minus 1 dx. Okay, as we approach this problem, it's important for us to be able to distinguish between when we're going to use natural logs. And how do we know that? Well, I want you to recognize that you have 1 over or something over, and then you have this 4x minus 1. Well, think of that 4x minus 1 as your u. If that is your u, then you can see how you'd have 1 over u, which then sets you up nicely to take the integral, and you would get natural log of u plus c. All right, so like I said, when we set these problems up, almost always the denominator is what we set to be our u. And so we're going to go ahead and say that u is equal to 4x minus 1. So du would equal 4 dx. So du over 4 equals dx, and now we're ready to plug it back in. So now I have the integral of 1 over u. In place of dx, I'm going to put du over 4. And so if I were to kind of clean this up, my constant, 1/4, would come out front. The integral of 1 over u du, which of course I could rewrite that because du times 1 on the top is du over u. And so now I see that integral of du over u, and then I can go ahead and take the integral of that, and I get 1/4 natural log of u plus c. Last step is to replace the u with the 4x minus 1. So I have 1/4 natural log of 4x minus 1 plus c. And that is my final answer. And again, I want to point out that I could also leave this answer as 1/4 natural log of absolute value 4x minus 1 plus c. Again, because of the rule that I can only take the natural log of a positive number. And so like I said before, you will see the answer both ways, and so you should be prepared to give it both ways and also prepared to recognize it both ways. Okay, number 3, the integral of x plus 1 over x squared plus 2x dx. All right, so once again, I'm going to take the integral of this, and again, I want to recognize that I have to use u substitution. Okay, if I Notice that I have a denominator that is not just a single term that I can divide into both terms in the numerator. That's a perfect opportunity to use u substitution. So let's go ahead and give that a try. Okay, so off to the side, I'm going to go ahead and set my denominator as my u value. So u is equal to x squared plus 2x. All right, now go through the process. du equals 2x plus 2. All right, dx. And I'm going to divide that whole thing away to solve for dx. So I'd have du divided by 2x plus 2 is equal to dx. All right, so let's go ahead and see how this works. So if I say the integral of, the x plus 1 is still there, so I'm just going to leave that as x plus 1 on the top, over u, then times, make that line a little shorter, then times, instead of dx, I'm going to put du over 2x plus 2. All right, now the idea is that I want something to cancel. So does anything stick out to you that you could do with these two terms, the x plus 1 and the 2x plus 2? That's what I want to cancel. And hopefully you're recognizing, oh wait, 2x plus 2 can of course be factored. And so I could write this as the integral of x plus 1 over u times du over 2 quantity x plus 1. Now I can cancel out my x plus 1's. I can pull my constant of 1/2 out in front, and so I get 1/2 times the integral of du over u, which I, of course, can recognize as the natural log of u. So this is equal to 1/2 natural log u plus c. Last thing I need to do is replace my u, and so my final answer here is 1/2 natural log of x squared plus 2x plus c. Okay, as you approach this next problem, it might throw you off. You have the integral of e to the negative x over 1 plus e to the negative x dx. So we kind of have two different rules here. We have exponential, and we also have this fraction where the denominator is a binomial. So which one am I supposed to use? Well, if we start off just by giving it a try and saying, let's set our exponent equal to u. So if I went ahead and said u is equal to negative x, so du would equal negative dx, or negative du is equal to dx. All right, if I went ahead and replaced things, let's see if it worked. Remember, we know if it works if everything ends up in terms of u, and it allows us to go ahead and take the integral in a way that we understand. So here I would have the integral of e to the u over 1 plus e to the u, and then times negative du. All right, well, everything is in terms of u, but did that get me any further? No, I still can't take the integral of this. I don't have any rule for taking the integral of e to the u divided by 1 plus e to the u, and so this is not going to help me. And so I did need a different method. Well, if setting the exponent equal to u didn't work, let's try our second method of setting the denominator equal to u. So u is equal to 1 plus e to the negative x. Du is equal to e to the negative x times negative 1. So I'm just going to stick that in front, and then dx. All right, I'm going to divide both sides. So I'd have du divided by negative e to the negative x equals dx. All right, so now let's try to replace things and see if this will help us out. So if I have the integral of e to the negative x over u, and then in place of dx, I have du divided by negative e to the negative x. All right, I can see already that this is definitely going to help. My e to the negative x is going to cancel out. This negative can come out in front. So I have negative, the integral of, and what's left is what I want, du over u. Fantastic. So that means I have negative. The integral of du over u is, of course, natural log of u, and then plus c. Okay, and so last step, negative natural log of 1 plus e to the negative x plus c. And that is my final answer for that one. All right, next one we're going to do is a definite integral. The integral from 0 to 1 of 3x squared over 2x cubed plus 8 dx. Again, I'm recognizing that I have a denominator that is a binomial. So I'm going to start off right away and take that as my u. So u is equal to 2x cubed plus 8. All right, why don't you go ahead and pause it. Pause the video. Continue on with this problem. Go ahead and take the derivative of both sides. Do the substitution back in. Don't forget to substitute also in for your bounds, your lower and upper bound. Okay, work through the problem as far as you feel comfortable with, and then come back and see how you did with your answer. Okay, so let's just I worked it through, and then we obviously have more to finish, but I wanted to kind of bring you back here and make sure that you were correct up to this point. All right, so I went ahead and took the derivative of both sides, solved for dx, so got du over 6x squared. Then I did my substitution. So the integral of, I held off on the bounds for a minute, okay, and I did the 3x squared divided by u, because 2x cubed plus 8 was u, times, instead of dx, I replaced it with du over 6x squared. Then I was able to do some canceling. My x squareds canceled, and my 3 canceled into my 6 2 times. All right, now I went ahead and fixed my bounds. So my 1, I went ahead and plugged it into this equation. Okay, so 2 times 1 cubed plus 8 is just 2 plus 8, which is 10. So I replaced my upper bound with a 10. My lower bound, well, 2 times 0 cubed plus 8 is 8, and so I replaced my lower bound with the 8. I just rewrote it to clean it up. So I pulled out this 1/2 and put it in front, the integral from 8 to 10 of du over u. At this point, I'm ready to take the integral and finish off the problem. So go ahead, pause the video, and work through it and see if you get what I get. Okay, so check your work here. I kept my 1/2, my constant out front, and then I bracketed it off and I said, all right, the integral of du over u is natural log, the absolute value of u, and that's from 8 to 10. Now, it's important when you have bounds to have that absolute value. And why? Because you're going to plug these in, and it's the absolute value. So if this, say this bound was from -8 to 8, you would still treat it when you substitute in as plugging in a positive number because we're using the absolute value. Okay, so I get 1/2 natural log of 10 minus natural log of 8. All right, now the AP is really sneaky with these answers, and they want you to know your log rules. First and foremost, this does not equal natural log of 2. You cannot actually subtract those and just subtract the 10 and the 8. It does not work that way. Hopefully, all right, if you think about when I said log rules, maybe something popped into your brain. That when you are subtracting 2 logs, that's the same as dividing, okay, the 10 and the 8. So if I wanted to rewrite this, one way I could rewrite it is 1/2 natural log of 10 over 8. All right, now I can clean that up one more step and make it 1/2 of natural log 5/4. Okay, so either one of those answers would be acceptable. The last thing they might do is remember when you have this number in front, it can be booted up as an exponent. So really, this is like the natural log of 5/4 to the 1/2. In other words, natural log of the square root of 5/4, or one more step, natural log of square root 5 over 2. So I'm just pointing this out to you because there is lots of different variations of the same answer that they could use. I would probably say the most common would be this one here. But they could go as far as this here. And so you want to make sure that you are aware that oftentimes with these problems, with this definite integral, it ends up that we have to use our log rules, and subtraction, of course, turns into division, and then go from there. Okay, we're going to try one last problem of the night, and I appreciate this is such an important topic. I appreciate you guys sticking with me and finishing strong here. So, if f prime of x equals 5 over x, and f of the cubed root of e is equal to 4, find f of e. All right, as you're approaching this problem, I notice that I'm given f prime of x, and then I'm given a value for f of x and asked to find f of e, so a different value. So hopefully something is jogging into your brain and telling you this is one of those initial condition problems. This is one of those want equals initial condition plus the change. All right, so that's what we need to make happen. All right, so we're going to say what we want. Well, that was f of e is equal to our initial condition. That's f of the cubed root of e plus the change. Now, the change is always the integral from the lower bound to the upper bound. What is our lower and our upper bound? Well, our lower bound is where we started with. That's our initial condition. That's our cubed root of e here. To our upper bound is where we want to end up, which is e, of f prime of x dx. Because remember, it's when you take the integral of f prime that you get f of x. All right, so now I'm going to plug in what I know. So I'm going to say f of e is equal to 4 plus the integral, the cubed root of e, to e of 5 over x dx. Okay, so 5 over x dx, that should stand out to you. The 5 can get bumped in front, so I could say is equal to 4 plus 5 times the integral of 1 over x dx. And again, it's the cubed root of e to e. All right, so this, of course, is 4 plus 5 times the integral of 1 over x dx is natural log of x. You can put the absolute value bars, and then you're going to go ahead and put your bounds. It's the cubed root of e to e. Okay, so as we continue on with this here, to clean this up and plug in our bounds, okay, so we have to go ahead and plug in our upper and our lower bounds. So I'm going to say this is equal to 4 plus 5 times the natural log of e minus the natural log of the cubed root of e. Okay, natural log of e, hopefully you realize, is just 1. So we have 4 plus 5 times 1 minus. And what about natural log of the cubed root of e? Well, the cubed root of e here would be natural log of e to the 1/3. Okay, using our log rules, anytime you have natural log e, that goes away and your exponent is what remains. That's your answer. So hopefully if that doesn't ring a bell, you just learned something new. So 4 plus 5 times 1 minus 1/3. Okay, a couple more last steps here. 4 plus 5 times 1 minus 1/3. Well, this would be 3/3 minus 1/3, so 2/3. Oops, 2/3. Okay, so that's 4 plus 10/3. Okay, in order to have a common denominator, I need to change that 4 to 12/3, and then I'm ready to go ahead and add those, and I get 22/3. So f of e ends up being an answer of 22/3. All right, thanks a lot, guys. That was a lot, I know. We're going to practice this a bunch next time, and hopefully the key is to be able to recognize when, especially when you take the integral of these fraction type problems, that you end up with an answer of natural log. So we're going to, like I said, practice more of this. Thanks so much, and I'll see you next time.